Okay, so let's finish this off because we've got two more parts of this. And this should be relatively easy to do. Come back to you, eraser, and get rid of this. And the last part, well, not the next last part of this question is, oh, let's see if we can erase. Oh, I can erase my calculator. That's so cool. All right, so the last part of this question is that we're going to take or the next to last part of this question. I'm going to get this right one of these times. X minus y. So I want to find the mean of distribution x minus the distribution y, and I can subtract the means. So this is the mean of x minus the mean of y, which is 10 minus 20 is negative 10. Okay, so I've got a value of negative 10. That's fine. What about the standard deviation? Standard deviation of x minus y. Again, we're talking about the variances. So this is going to be the variance of x minus y. And what we said, variances always add, so I'm going to have to take the variance of x plus the variance of y. Again, it's the Pythagorean theorem because variances are always going to add. Now, why do variances always add? Well, there's this big thing. You can look in the math box and never think about it. Standard deviation is distance, okay? And you cannot have negative distance. So you're always going to end up adding it. Because if I subtract here, I got a negative number here, it's possible I could get a negative standard deviation, and that makes no sense because it is distance. So I can't do that. So again, just like before, this is going to be c squared is equal to a squared plus b squared. Standard deviation squared is going to be 2 squared plus standard deviation 5 squared is 5 squared. Again, I'm going to get 29. It's the square root of 29. It's the exact same answer. Fancy that. All right, last part of this. This is the fun one. This is the one. This is the one that is going to be possibly the most challenging of this. Okay, because what it says is this. I've got it's E. It's E. Distribution x plus distribution x. It says x1 and x2, but really what you have is you have two different distributions. You've got distribution x and you've got distribution x. And I'm going to combine them together. Now keep in mind, what this means is that you've got a value that can take on any value in this distribution, and you've got another value that can take on any value in this distribution. And if you think about it, it's something like this. You take your iPod to to Best Buy, and these numbers are really wrong. Okay, you take your iPod to Best Buy, and they sit there and say, oh, yeah, we've got an average price of fixing your iPod of $10. Like, that's valid. And a standard deviation of 2. Okay? So it's an average of $10 and a standard deviation of 2, because sometimes it's just like, oh, you don't know how to turn it on. So it's an average of 10 and a standard deviation of 2. So you've got this and you've got this. Now what does this mean? Because what this looks like like it would be the exact same thing as saying, oh, isn't that 2 times distribution x? But it's not. Here's the difference between the two. X plus x would be, you've got an iPod and you take it and you get it repaired. And then you've got another iPod and you take it and you get it repaired. So you've got 2 iPods being repaired. As opposed to this distribution right here, 2 times x, where Best Buy is going to sit there and say, what we've done is we've doubled our prices. So this is doubled our prices, and this is iPod and another iPod. So when you see these questions, what you need to ask yourself is this iPod plus iPod, or is this 2 times the price of an iPod because they've doubled their prices? Now, it turns out actually that when we do this, when we do the mean of x plus x, which would be the mean of x plus the mean of x. Mean of x is 10, mean of x is 10. This is 10 plus 10, which is 20. 2 times the mean of x, which would be this. It'd be the mean of 2x, which is 2 times because the mean changes by the multiplier. 2 times the mean of x. This is 2 times 10, which is 20. You get the same value. But here's the problem that we have. The standard deviation, and you know what, I'm going to erase this because I want this space. So the mean's going to be the same, but this is the mean of x plus the mean of x. So I'm going to erase this. And purple looks good, doesn't it? It does. I'm going to erase this. Okay. So, and let's take a look at the standard deviation of 2x. Standard deviation of 2x, which is, we say to ourselves, okay, does the standard deviation change by the multiplier? The answer is yes. This is 2 times the standard deviation of x, which is 2 times 2, which is 4. But if I took the standard deviation of x plus x, I've got 2 independent distributions, because what happens to this iPod is not going to be the same as what happens to this iPod. So they should be independent of each other, and I can combine them. Whoops, I don't want the mean, I want the standard deviation. Hang on, I can do this. Shwoop. So, wait for it. Standard deviation of x. This works good, it does. Trust me, we'll be all right. And I'm not adding this out because, you know, I'm not going to put that much effort into this. Come on. There we go. Standard deviation of x plus x is, and I have to work with the variance because I've got 2 different distributions. So this is going to talk about the variance of x plus x, which means I'm going to talk about the variance of x plus the variance of x. So I have to, at this point, I have to square the standard deviation. 2 squared plus 2 squared, which is 4 plus 4, which is 8. And then I have to take the square root to get back, and the square root of 8, second square root of 8 is equal to 2.82. So the standard deviation is 2.83. Sorry, 2.83 versus 4. So x plus x is 2.83, 2x is 4, and is there a difference? Well, obviously there's a difference, and which one it is matters terribly. So you need to ask yourself, as you're doing this question, is this iPod plus iPod, or is this 2 times the price of an iPod? That's the question that you need to ask yourself, because the mean's going to be the same, but it's the standard deviation that is going to be different. So be aware of that. 2 times iPod, doubling the price, or iPod plus iPod, because I've got 2 iPods. Okay, now let's extend this just a smidge further and ask ourselves, okay, so what happens if I have a third iPod? What if I've got iPod plus iPod plus iPod? All right, so that's the mean of x plus x plus x, which is the mean of x plus the mean of x plus the mean of x. 30. Easy to do, okay? What about the standard deviation? What am I going to do with the standard deviation? Standard deviation of x plus x plus x. Well, that's the variance of x plus x plus x, because we have to work with the variant. So, what does that mean we're going to end up doing? Well, but it's not the Pythagorean theorem, because the Pythagorean theorem triangle only has 2 legs and 1 hypotenuse. Well, just pretend you've got a 3-legged triangle. So just add another variance, okay? It's going to be the variance of x plus the variance of x plus the variance of x. We adapt, we move on. Okay, I've got 3 terms, I'm going to have 3 variances. Does this mean I take the cubed root? No. We're not taking the cubed root because we have 3 things. We're taking the square root because we are squaring. So I would take the standard, oh, stop that. I would take the standard deviation, which is going to be 2 squared for standard deviation 2 squared for standard deviation 2 squared 4. So I'm looking for the square root of 12. So the square root of 12 is going to be 2 times the square root of 3, because the square root of 4 times the square root of 3. 2 times the square root of 3 And that would be your answer right there, okay? So, chapter 16 done and out of the book. Holy cow, that was a lot of work.